Welcome to the YouTube channel named as CAT OMETs by Manoj Mahajan. We have already started the QA Mind Boggling Concepts Series relevant for CAT and OMETs. In this series, we are going to cover up 200 plus concepts. And of course, you are going to see never seen before concept. So this is concept number 2. Already I have covered concept 1. You can watch the video, which is uploaded already on the channel CAT OMETs by Manoj Mahajan. And make sure that you subscribe to the channel so that you can cover up all these concepts on the channel. So let's read the question first. How many integers between 1 and 420? So 420 is a very good number too. Both inclusive are divisible by exactly 2 of the 3 numbers, that is 3, 5 and 7. So these are the 4 options also which you have. You can look forward to comment in the comment box and you would be surprised to see the right answer in a while. And maybe you get the answer correct, but the solution would be extremely different, which you must not be using it. So let's see how we're going to look at the trick shortcut over here in this question. So if I come to the trick shortcut, so just remember some constraint out here. So the first constraint which I have over here, let's say if I look in this problem, what is the number we have? 420. And over here we have the numbers 3, 5 and 7. So you can easily see over here that the number 420, if I do the prime factorization, it comes out to be 2 square into 3 into 5 into 7. So first thing, the number 420 is actually a multiple of these numbers 3, 5 and 7, which we are using in the question. So if the number is not the multiple of the numbers which are given in the question, then maybe you can look forward to apply this trick also, but you won't get the answer directly. Now, what I mean by this is, let's say instead of 420, if the number would have been 430, and the same question we have. So what we could have done is, we could have first directly got the answer till 420 with the trick which I'm going to teach you in a while. And for the remaining range from 420 to 430, we could have done manually, right? So one thing is very sure that if you want to be very fast with this trick, so in that case, the number which I'm using out here should be a multiple of the numbers which are given in the problem. So that is the constraint 1 to be faster. Of course, you can apply for other numbers also, as I've given you one example of 430. Second, the numbers which I'm going to use in the problem, like 3, 5, and 7 I'm using. So they have to be co-prime. What is co-prime definition? The highest common factor should be 1. So these two constraints, if we take over here, we could have answered the problem very, very fast. So let's see how we're going to do it. So my question is that they have to be divisible by exactly 2. So what I'm going to be doing over here, let's understand. Let's say I want it to be divisible by 3, divisible by 5, but not by 7. That is case number 1. I want it to be divisible by 3, not by 5, but by 7. So I'm taking the 2 numbers through which the number would be divisible, not the third one. And the last case, we could have looked forward that not divisible by 3, but divisible by 5 and 7. So let's see how fast we are going to be in answering this problem. So what we are doing is till 420, starting from 1. See, every third number is going to be a multiple of 3. So we want multiples of 3. So what I'm doing is 1 by 3 of this. So 1/3 are multiples of 3. Similarly, if I look, every fifth number would be multiple of 5. So what I can do is I can calculate 1/5 of it. Now every seventh number would be a multiple of 7. So we do not want multiples of 7. So what I can do is 1 minus 1 by 7. So 6 by 7 numbers are not divisible by 7. So let's calculate this over here. 420 into 1 by 3 into 1 by 5 into 6 by 7. So finally, if I calculate this, this will give me 24. So 24 numbers are in the range from 1 to 420, divisible by both 3 and 5, but not by 7. Let's quickly do for the other case out here. So 420, I don't want with 5, but I want with 3. So 1/3, and not wanting with 5. So 1 minus 1 by 5 into, again, I want with 7. So 1 by 7. So finally, what I can write is 420 into 1 by 3 into 4 by 5 into 1 by 7. This is going to be 16. Let's come to the last case out here. So 420, I do not want with 3. So 1/3 numbers are divisible. So 2/3 will not be right. So 1 minus 1 by 3. I want it with 5. I want it with 7. So finally, if I write 420 into 2 by 3 into 1 by 5 into 1 by 7. So this gives me how much? That is 8. So the total numbers in this range would be nothing but 48. So 48 is the right answer to the problem also, which is option B out here. So we don't have to do anything extra out here. The problem is done over here. So even if you look, lot of other problems could have been also answered with the trick out here. Let me take one example. Let's say I want in this range 1 to 420 numbers which are not divisible by 3, 5, or 7. So what I would have done is 420. So I do not want with 3, I do not want with 5, I do not want with 7. So look, the superb trick what I would have done over here. So 420 into 1 minus 1 by 3 into 1 minus 1 by 5 into 1 minus 1 by 7. So problem is already done. I'm just telling you the use of this wonderful trick. If I create a question like this, numbers in the range 1 to 420, not divisible by 3, 5, or 7. So 420 into 2 by 3 into 4 by 5 into 6 by 7. So this answer, if I calculate, so this is nothing but 4. So what I'm going to get 6 into 4 is 24. 24 into 2 is how much? 48. And if I multiply 48 into 4, so that is going to be 192. So 192 numbers I have in the range 1 to 420, not divisible by 3, 5, or 7. So make sure that you subscribe to my channel CAT 2IM by Manoj Mahajan to learn such concepts more. So this is the second concept. We are going to come up with a series of 200 plus concepts relevant for CAT and the OMETs. Thank you so much.